The first question given is find the current supplied by 10 volts battery for the following network. So in this network, we have to find out the current passing through the entire network. So for that, the formula is to find out the current, I is equal to V by R equivalent. The voltage is given in the problem, that is V is 10 volts, and you have to find out the equivalent resistance. So the value is 10 volts, and how can we find out the equivalent resistance? So let us see these resistors. Here 3 ohm and 5 ohm. If you observe these two resistors, these are neither in series nor in parallel, because in series connection the current must be same passing through all the elements. In 3 ohm and 5 ohm, here it is a junction point. At this junction point the current will divide, so the current passing through 3 ohm and 5 ohm are not same, so those two are not in series. Then just check whether those two are in parallel. So parallel means the two resistors must be one across the other. The one end of the two resistors are connected here, but the other ends not connected. Suppose if the other ends are connected like this, then those two will become parallel, but it is not connected like that, so those two are not parallel. So these two are not either in series nor in parallel. No two resistors are in series connection nor in parallel connection. Now check if there is no series and parallel connection, then check whether the resistors are connected in star connection or delta connection. So in this case, this 2 ohm, 3 ohm and 12 ohm, these three resistors are in the form of star. So if you convert the star connected networks into delta network, then your problem will be easier. So let's convert the star connected network into delta. So I will draw the star connected networks. These three resistors are connected in star. This is 2 ohm and this is 3. And this is 12 ohm. Now we have to convert these three into delta network. Let us first find out the terminals of the star network. This is one terminal, and this is second terminal, and this is third terminal. And this one is called neutral point, where the one end of all the three resistors are connected to a point. That point is called neutral point in star connection. So in between the remaining three terminals, you have to connect a resistor that is in delta. So between these two, I'm connecting one resistor, and here one more, and between these two resistors, I'm connecting one more resistor. Now these three are in delta. So your delta network will be this. So after replacing the star network, you have to connect this delta. But we don't know these delta values. So mark these values are R1, R2, R3. You have to find out these values. So how to find out these values? So I'm marking the resistors in star connection are RA, RB, RC. RA value is 2 ohm, RB is 3 ohm, and RC is 12 ohm. Now to find out the resistance in the delta connected networks, R1 is equal to, you have to multiply each two resistors in the star connection. Let us suppose RA and RB two resistors, multiply those two, RA, RB, and again next two resistors, RB, RC, and next two resistors, that is RC, RE. multiply two resistors, every two resistors, then add all those by, you are finding R1 resistor. So here it is the R1. Exactly to this R1 resistor, opposite resistance is RC. So divide the whole thing with RC. That will be your R1 formula. So after substituting RA, RB, RC values in this equation, you will get R1 value as 5.5. So next one, we have to find out R2 next. So again for R2 also the numerator will be same, RA, RB, RB, RC. For all the three resistors, the numerator will be same. By, so where is the R2? This is R1 and this is R2 in delta. So for this R2 resistance, exactly opposite resistance is this 2 ohm. So divide with the 2 ohm is RA. Divide with RA. So that will be your R2. So remember the formula like this. Multiply every two resistors in the star connected network and add all those three. Then divide with a resistance that is exactly opposite to the one which you are finding. Suppose you are finding R1 resistor. For R1, exact opposite resistance is RC. For R2, exact opposite resistance is RA. And for R3, exactly opposite resistance is 3 ohm. For this 3 ohm is the opposite resistance. Then the value will be 33 ohm, R2 value. In the same way, R3, numerator will be same. You have to divide with RB. Then you will get R3 element. So R3 is 22 ohms. So these three are the resistors we got now. Now we have the delta network. Now replace these three star connected resistors with delta and redraw the circuit. So only those three resistors you have to replace. The remaining resistors as it is you have to draw. So between these three terminals, previous those star connected network connected. So between those three again I'm connecting the delta network. I'm replacing the star with the delta. So now these values are R1 value we got 5.5 and R2 value is 33 and R3 value is 22. And this resistance is 4 ohm that is given in the network and this is 5 ohm and voltage is 10. Now if you look at here, these two resistors are exactly one across the other. So 4 ohm and 5 ohm are in parallel. So the parallel combination is 4 into 5 by 4 plus 5. That will be equal to 2.315. Next, here these two resistors, 33 and 5, again those two are also in parallel. So 33 into 5 by 33 plus 5, so that will be equal to 4.342 ohm. Now replace those two parallel combination with the equivalent resistance. By replacing these two, this is the equivalent, and this resistor, this is 22. This equivalent we got 2.315 and this equivalent 4.342. Now 2.315 and 4.34, those two are in series. So we have to add 2.315 plus 4.342. Replace those two with 6.657. So I'm replacing those two series combination with 6.65 and this resistor 22. Now 22 and 6.65, these two are in parallel, 6.65. So this parallel combination will give you 5.11. Equivalent is 5.11. So the total equivalent resistance of this network is 5.11 ohm. So then current I is equal to V by R equivalent. Voltage is 10 volts and the resistance we got is 5.11. Then its value is 1.95 amperes. So this is the value. I hope you understand.